Welcome back to RamZland. Today we're learning about quantum levitation, and we have a track here that's made of really strong neodymium magnets, and we have discovered that there is a quantum levitator that's made of yttrium, barium, copper oxide that you can lock in position over a magnetic track, and it'll levitate, it'll float. Special ceramic that actually bends the magnetic field around it, that allows it to float over the neodymium magnets. But what's special about this superconductor is that there are little holes, little imperfections in the superconductor. And if we scroll down, we can see the crystal structure of this alloy. And you can see there some spaces. Do you see some spaces down there? And these are called tubules. These are called flux tubules that allow just enough magnetism to pass through so that the levitator, the superconductor, is locked in place. So over here we have some liquid nitrogen, and we're cooling some of these yttrium, barium, copper oxide conductors here. And we're letting some of that liquid nitrogen get inside. And you can see that it's starting to float in place there. And would you give that a nudge and see what happens, Joseph? Give that a nudge. What happens there? It looks like it's floating over the track. And what's neat about this is as it expels the magnetic field around it, those little openings in the crystal structure of the yttrium, barium, copper oxide alloy allow just enough magnetism to pass through the superconductor to lock it in place. So it doesn't need rails. Like when I was a kid, we had this was the big thing. You know, we had a magnet that repelled another magnet, but it had a rail holding it in place. This has got no rails. There we go. Okay, give that a nudge. Give that a nudge. There we go.